So this is a quick hitter talking about the row space and the column space. So the row space of A is the non-zero rows in REFA, and it's a basis for the span of the row vectors of A. Then the column space of A is the set of column vectors in A that correspond to the pivots in REFA. Okay, and we should say it is the column space of A is a basis for the span of the column vectors of it. We have A here. And we've got 1, -3, 1, 2, 1, -2, 0, 1, 3. And we want to find the column space and the row space. Notice that both of these guys require us to have the row echelon form. You could do a reduced row echelon form, by the way, for the column space as well. For our purposes right now, right, there's some differences as to how we find the row space if you're watching other videos. It's okay. They basically end up being the same span. They're just written differently. The basis looks different. But what we're going to do is we're going to use the REF. So REF of A is going to end up equaling -3, 1, 1, 0, 7. So what I'll do first is I'll find my row space. And my row space is going to end up equaling, row space of A will equal the non-zero rows of REFA. So that's all three of the rows. Okay? And that's -3, 1, 1, 0, 7/3, 1/3, and 0, 0, 25/7. Which, by the way, is R3. Three vectors in R3, they're all linearly independent. They form a basis for R3. Then our call space, okay, the base generated from our call space is going to be the vectors in A, right? The vectors in A that correspond to the pivots in REFA. So here's one pivot, here's the second pivot, there's the third pivot. So it's actually going to end up being all three of the column vectors. So that'll be 1, -3, 1, 2, 1, -2, and 0, 1, 3. And that's our call space, which also ends up being R3. Okay, because it's got three linearly independent vectors in R3. And that's it. That's all you got to do. All right? If we happen to have a zero row, we would have only chosen, right, two of the row vectors here. And had we had, one fewer pivot, we would have only had one fewer column. Okay? From the perspective of how we think about subspaces, right? Okay? Right? Or span, what we're saying here with the call space is that wherever we have pivots, those are going to be the vectors that we need in order to have the span of all three of the vectors. One of them is going to end up being redundant if we don't have a pivot for it, right? It's going to end up being free. It's a free variable, okay? Same thing basically with the row space, right? Except we're going to be thinking along the lines of the rows, right? If we have a zero row, that row, okay, was not necessary in terms of the information from the rows. So consequently, we kind of got rid of it, and we're only going to keep the non-zero rows. All right? That ends this video.